Welcome back, ladies and gentlemen. We are now in topic 2, looking at packet 1, also known as lesson 1. This lesson and packet has a lot of vocabulary, so I wanted to do a video dedicated to that. We did go over this in class, but I just wanted to put up this video for people who may have been gone, maybe need a little reminder, and so forth. So, a central angle. Okay, so for lesson 1, we were talking a lot about circles. So a central angle is an angle whose vertex lies on the center of a circle. Okay, so for people who, I apologize, my pen's warming up here. Here we go. For those of you that might not be super great, who might not love words, I should say, who might not be English people, an illustration for you. Okay, if we have my circle, and then I'm going to create an angle, and its vertex is going to be at the center of the circle. So here is my center, right? And then if I were to create an angle off of this, I could create any angle I wanted. I'm just going to go ahead and do this. Okay, any angle I create, as long as its vertex, or the point of my angle, is in the center, it is a central angle. Okay, so that is what we're looking at. Next, we're going to talk about major and minor arcs. Okay, before I describe what a major and a minor arc is, I will just start by describing what an arc is. I think it's easiest to do this with an illustration. Okay, an arc is, if I have 2 points on the edge of a circle, or lying on a circle, okay, an arc is the distance between those 2 points following the curve of the circle. It's an arc. For those of you that have played basketball, you shoot a shot behind the arc, the 3-point line. It's called that because it is part of a curve of a circle. Okay, so from this point here, so we'll go ahead and label this A, B. So from A to B along the outside of our circle, that is an arc. Okay, and then from B to A, still going clockwise, okay, that would also be an arc. Okay, so for 2 points, there's 2 arcs that are created, and so we label these arcs by major and minor arcs. So major, so we have major and minor. So major, I'm just going to go ahead and put larger of the 2 created arcs, and then of the 2 created arcs being of the 2 that I created just through this example. Okay, larger of the 2 created arcs, and then that would mean that minor is the smaller of the 2 created arcs. Okay, and so we can see this. So from A to B, okay, we can see that from A to B is a lesser distance than from B to A. That is going clockwise. If we were going counterclockwise, that would obviously flip. But so this arc here that I have, that's a little darker now because I've traced over it a few times. Okay, this arc would be an example of your minor arc. So I'm just going to go ahead and put a little baby minor as a little reminder. Okay, as a little label here, minor arc. And then this one that's that's not highlighted or that's not dark, would be an example of our major arc. So a couple different ways that you can look at it. For those of you that are English people that like the words, the definitions, here we are. And then for people who like this illustrations, there is that as well. So the next one we're going to talk about a secant line. I'm just going to shift this up here. Okay. In your packet, it is just called a secant, but most often, well, secants by definition are lines, so saying secant line is not incorrect in any way. Okay, so here we go. We're going to talk about secant lines. So again, I'm just going to go ahead and start with an illustration, and then I'll give you some words to back that up. Okay, so I have a circle. A secant line is a line, okay, and I'll write this down in a second. I'm just going to say it for now, is a line that crosses through or that touches a circle in exactly 2 points. So you can see that this line, remember that it's denoted as a line because of these arrows. It goes on forever. That has exactly two points, okay, that touch the circle. So if I were going along this line, say I started way down here because it goes on into infinity, right? I'm going up the line, up the line, up the line, and touches the circle once. Keep going along the line, touches the circle twice, and then keeps going, and we know that it will never touch the circle again as we go off to this top right area. So this is a line, remember again, line denoted by those arrows, that does touch the circle in exactly 2 points. So a line that, and instead of saying touches or crosses, I'm going to go ahead and use the fancy term that intersects with a circle 2 times. Okay, so again, 1, 2, secant line, boom. Okay, so our next one, our next vocab word actually relates directly to secant line. This is called a chord. Okay, so a chord, a secant line is a line, again, which means these arrows, right? And a chord is a line segment. Remember, a line segment is denoted, so if you forgot, okay, just right above line segment here. A line segment is basically a line, but instead of having arrows that goes off into infinity, a line segment has 2 endpoints. So this would be, if I labeled these A, B, this would be line segment AB. So a line segment whose endpoints lie on a circle. On A, and I just want to make sure. I was just checking to make sure I wasn't off the screen there. Whose endpoints lie on a circle. So the reason a secant line and chord are related, we can see our secant line, a line that touches or that intersects our crosses, that intersects or crosses our circle 2 times, 1, 2. And our chord, they're related because this line segment, if I were to cover up my arrow here, and if I were to cover up my other arrow up here, this line segment that's created, okay, that is a chord. So secant lines and chords are hand in hand there. Okay, so the secant line is a line that goes through, intersects our circle twice. A chord is the line segment that is created from a secant line, or it is just a line segment whose endpoints lie on a circle. Okay, next one, and I'm running a little bit out of room. Here we go. Okay, so there is our chord. So now we're going to talk about an inscribed angle, and I'm actually going to leave this illustration up because this is related as well. So now I have an inscribed angle. Okay, so an inscribed angle. So we already talked about a central angle. I'm just running back up here. Okay, a central angle is an angle whose vertex lies on the center of a circle. Okay, so an inscribed angle now, okay, is an angle whose vertex lies on a circle and whose sides are chords. Okay, so an inscribed angle, if I were to draw an inscribed angle, I'll go ahead and illustrate it right here. Okay, an inscribed angle has the vertex or the point of its angle on the circle, and then its 2 sides are chords. So again, remember, a chord is a line segment whose endpoints lie on a circle. So if I took one, I drew one line, okay, I have one side of my angle that is a chord, okay, so that's half of my inscribed angle, and then I have another side of my angle that is also a chord, again, whose endpoints are both lie on the circle, or whose endpoints both lie on the circle, and then the measure of my angle would be right in here. Okay, and so you could create any type of inscribed angle. Just with these 3 points, you could draw it a couple different ways. I chose to draw it this way just because I was feeling that way. You could draw it different ways if you'd like. Again, your only restrictions are that the vertex lies on the circle. So in this case, if I was going to go C, D, E, okay, my angle CDE, D would be my vertex, so D lies on the circle, and then my sides, DE and C, and DE, DE and DC, those are both chords, and those are the sides of my angle, so by definition, this is an inscribed angle. Okay, so the next one we're going to talk about also has to do with inscribed angles a little bit. Okay, so I'm going to be right up here. I'm going to be talking about an intercepted arc. And these are all in the pack as you work through them. I just wanted to go over these kind of all at once so that you can have them all in one place. So an intercepted arc, an arc that is created by is created by a central angle or an inscribed angle. And this is not the formal definition for an intercepted arc, but when I illustrate it, hopefully you can see what I'm talking about here, okay? So if I have an intercepted arc, so we already talked about what arcs were. If I have 2 points on my circle. An arc is the distance along the circle, the curved part, okay, that is the distance between my 2 points. So that is an arc. So an intercepted arc is an arc that is created by a central angle. So remember, a central angle has its vertex in the center of the circle. So if I had a central angle that looked like this, okay, if I had a central angle that looked like this minor arc, the minor arc that's created by these 2 points, would be my intercepted angle, which makes sense because if I were to keep on drawing these sides off into infinity, okay, this arc from here to here is what I'm intercepting as part of the circle, so this would be my intercepted arc, okay? Now the same is true for an inscribed angle. So I have an inscribed angle whose vertex lies on the circle over here, and then I would connect these lines, and I'm just extending them so that, again, you can kind of see that. Apologize, I kind of missed there. I'll just make my circle bigger, right? Okay, so again, we can see that this arc is the arc that is intercepted by my inscribed angle. So again, that is not the formal definition. I believe on your homework for your packet, they have a different definition, but you can get that definition that they have from this one and from understanding that what an intercepted arc is using this illustration. So now, okay, I'm going to go ahead and slide this up. We're going to talk about tangents. Tangents and secants are related. Okay, they are both lines that touch circles. So a tangent, okay, I'm going to put tangent line again because a tangent is always a line. A tangent line is a line that intersects a circle exactly one time. Okay, so a secant line, if you remember, intersected our circle twice. A tangent line now will only intersect our circle one time. So let's say here's my 1 point where my tangent line intersects it. I would have to draw a line kind of like this, right? And it would only touch the circle one time. Okay, so anytime you draw a line that touches your circle in one spot, and so it's imperfect because my circle isn't perfect, my line isn't perfect, but we could say, you know, somewhere right along there, maybe that's my 1 point. Here's another tangent line that you could draw. If you want a pretty cool illustration, just because I think math illustrations can be cool sometimes, okay? If you just keep putting points and keep drawing tangent lines, okay, this one might get a little wonky. There you go. Okay, you get some cool drawing. Anyway, so that's not what I'm getting at here. These are all tangent lines, though. Examples of tangent lines. You can see if you keep going, you'd get a bunch of straight lines that kind of form a circle there. So, yes, a tangent line is a line that intersects a circle exactly one time. Okay, next thing, so we had secant lines and we had inscribed angles. Those were related. So now tangent lines and circumscribed angles are related. Okay, circumscribed angles, an angle whose sides are both tangent lines. Okay, so an inscribed angle had a vertex. Well, here, I'll just flip it over. We'll just go right back over really fast. Central angle, so far we've seen vertex in the center. Sides, we didn't have any specifications. For an inscribed angle, we had a specification on both the vertex and the sides. And now, for a circumscribed angle, we only have a restriction on the sides of our angle. So an illustration of this, okay, if I have my circle, say I have a tangent line like this, okay, and then say over here, I have another tangent line, and those two tangent lines cross. This point, okay, so they cross right here. These are my two tangent lines that cross, and they would keep going on forever. Okay, so this angle would be an example of a circumscribed angle. Now, the one thing that you have to be careful on, okay, is that if you have two tangent lines that are parallel to one another, so an example over here, okay, if I have, let's say that these two lines are perfectly parallel, which of course with my free drawing this, they probably won't be, but we can use our imagination, okay? If I have two tangent lines that are parallel lines by definition will never cross over, so there is no circumscribed angle that we can create from these two tangent lines in particular. Okay, so just something important to understand about that. Any other tangent lines, though, even if they aren't perfectly parallel, they're just very, very close, they would intercept at some point. It would just be some point very far away from the circle. So circumscribed angles, again, angles whose sides are both tangent lines. Okay, a couple more definitions for you here, and then we can move on to doing some of the activities. I'm going to go ahead and try and not get that completely out of the screen. So here we go. First one is a theorem. Okay, so a theorem, and here actually, yeah, so a theorem is something that in math we talk about. It's been proven. It's something that, so if I took a class once, I'm kind of rambling here. I took a class once in college that was basically all theorems, and it was gross. It was from a book. You would have theorem, 3.1.5.4, and you would basically prove things just by putting theorems all together. So a theorem, okay, now that this is a formal definition, I've been giving you kind of informal ones, but I want you to have the formal one for this. It is, so a general proposition and then so a general proposition that can be proved, or that has been proved, I guess, that can be proved through a line of reasoning. Okay, this is a little different than the definition I gave you in class. They both get to the same thing. So a general proposition that can be proven through a line of reasoning. Okay, and most theorems that you hear about in your math books have been proven, but a theorem in general is just something that can be proven. Okay, so a general proposition that can be proven through a line of reasoning. So the example that I gave you in class said that we can prove it with a definition, we can prove it with postulates, we can prove it with all kinds of different things. Pretty much anything that has been proven or that is accepted as true, we can use to take a proposition or a theorem. Okay, we can use those things that have been proven as true or that are accepted as true and build upon those to create a theorem, something that is always true. Okay. Last one, a postulate is a mathematical. Here, let me let me look at my notes really fast. Where did it go? A mathematical statement that cannot be proven, but is accepted as true. All right, so basically, like I was saying, a theorem can be proven with definitions, postulates, okay? A postulate is a mathematical statement that cannot be proven but is accepted as true. An example of this is the idea that quadrilaterals have four sides. So, okay, when the Earth was created, however you believe it was created, sides with four squares were not called quadrilaterals. Someone, somewhere along the line in history, decided that for mathematicians to all be able to talk about shapes in the same way, he or she decided that quadrilaterals should be shapes with four sides. Okay, so because that was decided and because the rest of the mathematical community decided that that was a good idea, we all now know quadrilaterals as shapes with four sides. Okay, so it can't be proven that a quadrilateral has four sides because someone just decided one day that that would be true, but it is accepted as true because when I was in school, when your grandma was in school, when your great-great-great-grandma was in school, or grandpa, okay, they all learned that quadrilaterals had four sides, and that has just been something that has been accepted as true. So in a theorem about quadrilaterals, if we had to talk about how they have four sides in order to prove it, that would be something that we could use. So that is an example of a postulate. I hope that this vocab video helped you out. Yeah, I will see you guys in class. Have a great day. Adios.